Namaskaram everyone. Welcome back for another day of webinars. Dear students, the first session for today will be Mathematics 1B. The continuation of the chapter Straight Lines, which was started earlier, will be taken over by ESHWARI madam. Madam is the principal of SMS. Madam has already dealt the various forms of straight lines. She gave an introduction and derived formulae using the formula for slope. In all the derivations, what was used, students? The slope, m is equal to y2 minus y1 by x2 minus x1, was used in order to derive the equations in various forms. And Madam will continue to derive few more equations and then reduce one form of equation into another one in today's session. I'm so honored to introduce Mrs. ESHWARI, Principal of Munagala, to continue with Straight Lines chapter, session 2. Madam, over to you. Thank you, ma'am.
Thank you, ma'am. Thank you, Sridevi, ma'am. Good morning, students, and good morning to all the viewers of YouTube webinar channel of Telangana Model Schools, prestigiously being run. So here we go with the second lesson. Hope students, you remember we had the session 1 with straight lines. This is a part of Mathematics 1B. And so today, what are we going to learn? So let us recapitulate the lesson 1, what we have learned previously. And along with the things that we have learned, today we are going to learn about normal form, symmetric form, general form, conditions for parallel and perpendicular lines, and reduction of these forms into various forms, the general form into the different forms. So let us recapitulate what we have learned previously. We started with the definition of slope of a straight line, which you have learnt in your 10th class, which is the angle made by any line with the positive x-axis in the positive direction. So if you have x and y axis like this, and a line L makes an angle theta with x-axis, the tan of that particular value will give you the slope. This is what we have learned in the previous class. Now here, what are we going to see more? So here you can see that the slope is just not the acute angle,
but it can also be
an obtuse angle. So you can see that the angle made with x-axis in the positive direction is called the slope. So if you take the theta and calculate tan of that particular value, then we get what is called the slope. So in that process, if you calculate the slope of x-axis and y-axis, then the slope made by the line with x-axis, that is the angle made by x-axis with x-axis itself, is going to be 0, and hence the slope of x-axis is going to be 0. Similarly, what is the slope of y-axis? The slope of y-axis is going to be the angle made by y with x-axis, which is going to be 90 degrees, and hence tan 90. As you know, tan 90 is undefined or infinity. We have the slope of y-axis as infinity. So wherever we calculate, it is tan theta, the slope, and the slope of x-axis is 0, and the slope of y-axis is 90 degrees tan 90, which is undefined. Now, again, we have also seen that if there are two parallel lines, then the slopes of the parallel lines are equal, and the slopes of perpendicular lines are product of the slopes is going to be -1. Is it not? Just give me a moment. Somewhere the presentation got stuck. Yeah. So here you can see the acute angle and the obtuse angle. The slope m is tan theta, and the slope of x-axis is tan 0, 0, and the slope of y-axis is m equal to tan 90 degrees, which is undefined or infinity. Now, what happens to the slopes of straight lines if they are parallel? We have derived the condition for parallel lines, and if you remember, if there are two parallel lines, L1 is parallel to L2, then their slopes are equal. And if you have two perpendicular lines, angle making 90 degrees with each other, then the product of their slopes is equal to -1. So the other way around is also true. If the slopes are equal, the lines are parallel. If the product of slopes is -1, then the lines are perpendicular. And this is one formula that has been haunting you since 10th class. That is slope m equal to y2 minus y1 by x2 minus x1. We have also seen the different forms of straight lines in our previous class. The standard form, the slope intercept form, normal form, symmetric form, two-point form, and point slope form. All these forms we have seen, and in detail we have seen these forms and their derivations also. So hope you remember the standard form is ax plus by plus c equal to 0, and the point slope form is y minus y1 is equal to m into x minus x1. The slope intercept form is y equal to mx plus c. The intercept form is x by a plus y by b equal to 1. The two-point form is y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. So these equations we ought to remember, and my dear students, these equations play a very important role in the entire chapter, and you will be using these forms in your other subjects like physics and chemistry also. So please try to remember whenever there is a linear equation in x and y, then it obviously means it is a straight line. Now we go with more forms. Here, let us see certain examples with parallel and perpendicular lines. Now here we have got a question. Find the equation of the straight line through a minus 1 You can see on the left that there's one line passing through a minus 1 comma 3, whose equation we are supposed to find. For that, what are we given? The
Try to find out slope of the first line, which is passing through B and C. Now the slope of straight line BC is,
you can use the formula y2 minus y1 by x1, which to take one of b as 2 comma minus 5 and x2 y2 as 4 comma 6. Now this is 6 minus of minus plus 5 by 4 minus 2, which gives you 11 by 2. So the slope of this is 11 by 2.
Sorry for the inconvenience, children. There is a connectivity issue with the presenter, and we'll get back to you at the earliest. Please stay tuned.
Ma'am, seriously, ma'am, I'm unable to open on the I sent a mail to you if you can see. If somebody can host me and take up the PPT. Hello, ma'am.